I think we're fine now. Quiet now. Be quiet now. I think it's just start talking. All right. Hello, everyone. Welcome to the Gopher Motorsports Go4-24c Unveil. My name is Mike Marsden. I'm the internal combustion chief engineer. Yeah, tonight we're going to just be kind of going over what we've done this year, some previous competition results, and then we'll get you to the car, what you've all been here for, and show you all the car. Thank you for coming, by the way. It's really good to see a full room. Maybe next year we'll get a bigger one, but yeah, better too full than empty. So I'll have the rest of the officers introduce themselves, and then we'll get on with it.
And my name is Alexander Tong, sophomore studying computer engineering at the U, and I am the electrical lead at this year.
All right, my name is Stay Sonke. I'm the president this year, and I am computer science and finance major.
My name is Gavin. I'm the aerodynamics lead, and I'm a senior aerospace engineer.
It's Rafa. I'm the project manager.
My name is Connor, I'm the Master's lead, and I'm a junior in aerospace.
Sylvia Burkett, the power plant lead, and I am yet again aerospace engineering major studying.
I'm Paolo. This is me.
There you go. Yep.
All right, so as we just talked, this is kind of the opposite breakdown on our team. One thing that wasn't mentioned, we do build 2 cars every year. So tonight we're going to be unveiling the combustion car. On May 24th, in this exact same spot, exact same time, we will be unveiling the electric car. So if you have a lot of fun tonight, come back in a couple weeks and we'll go over it again. All right.
And then just talking about some of our membership breakdown, the majority of our team is mechanical engineers, but we do have a lot of students from a lot of other majors with aerospace, computer engineering, electrical engineering, and a lot of people just find a lot of there's just a lot of different people working in different spaces of our team. I know one thing that gets said a lot is like a pre-med student who's welding our entire frame in 2022, and there's just a lot of people that come and check out our team. And then years on the team, majority this year is 1 year. Then we also have a lot of 2 years, 3 years, kind of a younger team this year. And a lot of, yeah, for the age of team members, majority is junior team or sophomore.
All right, so going into why we're all here, what is this competition? FSA is an international competition that many colleges participate in. It's where students design, build, test, and compete with race cars against each other. So we will be heading out to Michigan International Speedway next Tuesday, and we'll be competing with this car against all those other schools. There's a huge rule book, and that kind of dictates how the car looks a little bit. They're pretty open with our interpretation, so there's a lot of creativity. One of the most exciting things at competition is seeing all the other teams' cars and how they interpreted the rule. And then, go ahead.
Why do we build our cars? Playford, I mentioned that there's a lot of different people that come to our team and learn a lot of different skills. There's also a lot of companies that work with us, and we work with them. They sponsor us in the interest of hiring on a lot of our members. A lot of our members have internships or full-time positions at our sponsors once they graduate or while they're doing their undergraduate or other stuff. And then we just have a lot of fun on this team. We have fun social events where we go like skiing every year, and we do movie nights and sometimes go to restaurants and such. We're just generally here to have fun and build amazing cars.
All right, getting into the competition, what it actually looks like. It's broken down into two types of events. Static events, which are where we're talking about how the car was designed, built, how much it costs, and so on. And then the fun ones, the dynamic events where the car is actually moving. Out of 1,000 points, the winner is the one that gets the most. Slide. So we'll go into kind of the breakdown of each one. In the design events, this is where we get grilled by industry professionals. So we will take the car, we will have judges from professional in the industry. They will be critiquing the car in 45 minutes. Our entire year of work summed up in 45 minutes. Very chaotic, very hectic, very fun, very stressful. This is the part where they're kind of critiquing, did we design the car properly? Did we follow the engineering process? Did we validate our decisions? Did we build the thing just to build it, or do we understand everything on the car? Out of the top 10 teams, they will go on to design finals, which our team has been striving to accomplish for a while now. Last time we went was in 2016. This year we are hoping to go, and we put in a lot of effort to make the car capable of doing so.
Talking about the cost event, there's also a significant section of our points. A big part of that points is like the cheapest car of our competition gets a lot of those points, but it's not completely that. There's also graded on accuracy and how well you're able to present on the cost of your vehicle. They give you a cost scenario, and you're supposed to figure out how to reduce the cost or change the cost around based on the different prompts that they give each year, as well as if they, for the accuracy, if they find anything that you lied about on your cost report, docky points. For the presentation event, this is something that our business team had a major focus on this year. Every year, our competition gives us a business prompt of, usually it's one about if you're to change the fundamental structure of your powertrain, kind of what would that look like, and what does the market analysis and all the business related things look like when that happens. We recently gave a presentation to judges about 2 weeks ago or so, and that went pretty well. And ultimately it's to just answer their prompt and have a good conversation with judges about how you can market your car and if you were to sell it as if it was a production version.
All right, now going into the dynamic event. So the acceleration event is pretty straightforward. We're just testing how fast your car can accelerate in a straight line, 75 meters. Car usually that is lightweight and has a high output powertrain as well in this event. There's some other things as well, like launch control that we're focusing on for this year. That'll help us do well in this event. This one's pretty straightforward. Skid pad, measuring your lateral acceleration. So you go into the figure eight, you do 2 turns to the right, 2 turns to the left. They're measuring how quickly you can do that. So they take the average of one of each turn. So go around twice on the right, they'll take the fastest of that. Go around twice on the left, they'll take the fastest of that. That is your time for skid pad. For autocross, it's a cone course. The drivers do not get any practice for this. You just get to walk the track beforehand. You only get 2 laps, yeah. So you go out there, you just have to full send right away, right off the bat. So this is kind of the ultimate test of the car's performance. Not the reliability yet. We'll get to that in a second. But usually the fastest car is the one that wins this event. And then endurance is the big one. This is a 22-kilometer race. Multiple cars on the track at the same time. Fastest overall takes the winner, or takes the win on this. So during the endurance event, you're also measured on your fuel usage, and for the electric car, you're measured on your energy usage. The most efficient team gets a huge boost in points for that as well. This event, only about 40% of teams finish it each year. For the IC car, we have failed to finish endurance since 2019, which has been really disappointing. So this year, we're hoping to come back strong and finally make it. All right, going over some results from previous years of teams. The team has followed kind of a continuous improvement across the years. So you can see an upward trajectory for the 2013-15. Then after that, 2016 through 2018, the same sort of upward trajectory took place. In 2018, the team suffered a chain failure during endurance, so that ended that short, dropping their result quite a bit. And then in the past few years, we've learned a lot of lessons. COVID really hit the team hard. We lost a lot of our members with a lot of knowledge, but we've been building ourselves back up, and we've been pretty proud with how we've done so far. So these overall finishes may seem low. In 2023, last year, we were on track for getting a fourth place finish, but we had a cooling failure in endurance. So we'll talk a little bit more about the performance of that car. But we're on our way to redemption. So some highlights on last year's car. The chassis is made of carbon fiber in the front and a steel welded space frame in the rear. With pretty high power output of all the team competition at 81 horsepower and 39 foot-pounds of torque. A lot of custom electrical modules on the car. We do pretty much everything electrical in-house, which is not very common amongst IC teams. And then the other big thing on this car, it got third place out of 100 teams in the autocross event. So very fast car, very capable car. For this year, we're going to be trying to get first place competition, which is incredibly bold, given our track record of failing endurance, but we'll talk on the next few slides of how we're going to get there. So we did a full analysis on our performance last year and essentially had our car performed at its full potential, ignoring the cooling system's faults, we would have finished fourth place overall and would have been second place in endurance events. So the car was very quick. It was capable of doing really well, being in the top 5. We've assessed where we need to be to get to first place, and on average, we need to do about 9.3% better in each event. So that is a fairly large number, but we're confident that we can get there. Also, amongst the top 5 teams last year, a lot of them have transitioned to electric vehicles. Only 2 out of the top 5 are going to be returning, so the competition is kind of decreasing a little bit, and we're trying to account for that when we're doing these projections as well. And so now we'll talk about what this car under the sheet actually looks like. Here's a 3D drawing of it, or a 1D drawing of it. We have a brand new cooling system, of course, to overcome our challenges last year, in the past couple of years. There is a fully redesigned wheel well, so that includes the brakes, the suspension units, uprights, and pneumatics point. We've revised a lot of parameters in our engine and how we tune it. So the engine is now fully closed loop with tuning and water pump control. And then we have a brand new live telemetry system. We just tested it yesterday on the car for the first time. We had it running in the back lot, and Alex was about half a mile away, actually getting the data that the car was putting out in live time.
Going through two brick build.
Going through 2 brick building, yep. Then we also have a drag reduction system on the rear wing, which will decrease the drag on the car by 40%. And then an updated aero package. All right. Now I've talked enough, so we'll hand it over to all of our wonderful sub-team leads.
So why it's not up here. So I'll talk about this. So this is the business sub team. Everything that they do involves stuff with like sponsorships, marketing, purchasing. Those are kind of the big 3. Also the budget, that's a big one for us, especially running 2 teams. It takes a lot of effort to make sure we stay on track and make sure we get everything ordered correctly. Another thing we talked about, the business presentations. That's the competition presentation. We go through that every single year on the business sub team, and they're mostly in charge of that, and we work with a little bit across sub teams to get that done. Some of the biggest things that people learn on this is marketing skills, accounting skills, and especially supply chain skills. That's one of the things that people don't realize about the business sub team is that supply chain is actually a huge part of this competition, just making sure you get everything in on time. And a lot of the focus of our presentations is on that. Additionally, social media and sponsor relations are a big part of it as well. Our social media accounts have definitely grown in the last couple of years, and we've been getting more and more sponsors on board. Huge important part of running this team.
About the big electrical highlights from this year. We have, as mentioned, we have a very, very custom electrical system on our internal combustion vehicle, which is not super common, but is incredibly useful for us. Main parts is having, it is super modular and configurable, where we can just plug in new devices at any time during the year. And this helped us a lot with during the last fall. We ran a very important load cell testing plan, and we were able to just plug in 2 modules into our CAN communication bus, we call it, and we're able to just get data for all of those, which would be nearly impossible within like a month with other teams. But highlights from changes from this year, we mentioned we have a fully custom telemetry module this year with an RFD 900 megahertz radio. And this is incredibly useful for us to get live data from our vehicle while it's driving. The important part of that is that when we're driving during our endurance event and other events, we can watch temperatures and different parameters in the car all for the driver. The driver does not have to pay attention to that. They can pay attention to driving on the road. And we can also watch things that it would be unreasonable to show to the driver while they're driving because they're not going to be able to keep track of all that. Doing that, watching live data for our test plans when we want to get certain data, like suspension testing, we want to look at very important parameters while it's driving. We can just get all of that immediately rather than having to sit the car down and plug in a USB and pull data off of it. So that is a big feature of what the electrical system is new this year, and that includes it also has the same data logging circuit as our power and logging module, which is our custom data logging module from the past. This allows us to have redundant data logging this year, which I've already found very useful as one device stops working for whatever reason. We're still able to have data, or I forgot to put an SD card in one device, which happens more often than I like to admit last year. Still able to get data from the vehicle, which is, if we don't have data and we're driving, we might as well not be driving during some of our drive-bys. Other parts is that it's incredibly easy to use. We made a incredibly easy to use software for all our data, basically, where you just have to load in the configuration and click a button to parse that data into a format that we can read, as well as one that will broadcast with the live telemetry. And then other things that we worked on this year was revisions to all of our custom circuit boards this year, primarily for improved serviceability and just a lot of new features, like adding load cell support, which measures the force on our shifting lever. We implemented that into our transmission controller control scheme. The DRS system, which is drag reduction system, we added that functionality to our transmission controller to be able to control the position of our servo that moves our wing. I'm sure Arrow will talk about that more. We increased the number of sensors, each of our sensor hubs around the vehicle, which are just places that we can plug in a bunch of sensors. We increased the number of sensors those support from 8-voltage sensors to 12-voltage sensors. We now have a high-speed USB circuit on both our power and logging module and our telemetry module, which just makes it incredibly convenient when you're not using telemetry to just plug into these devices and pull data off immediately. Like last year, that process would take like up to 10 minutes with the large files. This year, it's going to take like 10-15 seconds max. And then additional control dial was added to the steering wheel as part of our steering wheel module, and mounting with that module was improved. And then we also did a lot of important standardization with standardizing the size of all our custom circuit boards. Not all of them, but the majority of them where that was reasonable. Sensor hubs, telemetry, our transmission controller, and on our EV, our vehicle control unit, all the same size, so we can use the same enclosure for all of them. And that enclosure is also very configurable based on what module we're using in it, so we don't have to print too many different parts or lose track of parts. And then also important circuits that were used on all of our modules, very standardized. We had a boilerplate, just a hardware product for us to import first and start using. And then also all status LEDs would be the same colors, so you can look at a module and know exactly what's going on with it. And then this year we made an important decision to refurbish our previous year's wire harness rather than making it brand new. And this gave us a lot of benefits with saving us a lot of money. It sped up the manufacturing and testing process substantially. And we mainly chose this because although we were adding new features and remaking our modules, we weren't changing a lot of their connections internal to the vehicle. We had to add a little bit of workarounds with our transmission controller doing drag reduction system. We added a power overcurrent circuit on there, which would be a small thing that we would add to a wire harness if it wasn't that case. But otherwise, we were able to reuse most of it, and we were able to take time to ensure that the quality of that harness was really good. Making sure to put these heat shrink boots to cover all of our wires going to our connectors, making sure every single connection had those this year, and a lot of other various things we worked on. Bunch of pictures of stuff I described there. Next.
All right, so on the powertrain side of things, so the cooling system, as many of you know, as many of our alumni know, has been a repeated failure mode for the combustion car for the past however many years that I've been on the team. And our sort of repeated pattern that the team goes through each year is, okay, we're gonna do a bunch of cool engine stuff, and cooling is also on the list, but all the cool engine stuff becomes higher priority than the cooling system. Then we have a bad cooling system each year. So we all talked at the beginning of the year, Mike especially, and we decided, all right, cooling is our highest priority, because if you make all this horsepower and do all this crazy stuff, but the car overheats and the driver doesn't get above third gear, you can't really use any of it. So we did a complete cooling system redesign and complete rethink of kind of how we've been going at this design for the past few years. And we did extensive, to do this, we kind of just completely tested the whole like engine heat rejection situation. In the fall, we did this during our drive days, as well as on our dynamometer, which is kind of a engine testing rig that we have up on the 4th floor, that we use a university laboratory space, to help us test. So what we kind of did, it seems like the basic, or it sounds the most basic essential part of designing a cooling system is, okay, how much heat is your engine actually making, and how much heat do you actually have to get rid of? And that really basic first step actually hasn't been done in quite a while. So that was kind of the first thing we did. And we did kind of a test on our dyno, as well as driving, measuring how much heat our engine was producing, as well as how much heat our oil was producing. And then we talked to a bunch of companies that make custom radiators and racing radiators, and we decided on a company called PWR Advanced Cooling Technology. We were able to talk with them and give them our data, give them our numbers of how much heat the engine was actually making, and then they were able to produce two really big, I didn't put any pictures on here, but trust me, you'll be able to see them once this curtain comes off. Custom dual pass radiators. If this car doesn't cool, I have zero faith in heat transfer, like whatsoever. But like a huge problem as for why, or the big challenge for FSA cooling designs, and a reason why a lot of teams struggle with it, is because you are required by rules to run distilled water only. You cannot use coolant, because it's kind of really difficult to clean up on the track if you spill it. So cooling a high power, very hot motorcycle engine with water is definitely a challenge. Anyways, in other little improvements that we've made this year, we've been doing a lot of engine tuning and improvements with our dyno. So we kind of got, in the design event last year, our design judge was kind of skeptical that we used the closed loop alpha N tuning. Wait, we were open loop last year. Okay, all right. He was concerned that we did open loop alpha N tuning, which is kind of a way of tuning that is based off of your throttle position and the engine. And if you go into different parts of the world, parts of the country, such as Michigan, that have a different altitude pressure, your engine can behave a lot differently. So we did a bunch of changes with that, and we changed to closed loop alpha N tuning, and we have done a few changes as well to have our water pump, our electric water pump, be controlled by a PID loop, as well as having closed loop lambda control. So that'll be great for engine performance as well. We did some intake port modifications last year that raised our low end torque curve by quite a bit, and we were able to validate those ports at a flow bench in Polaris. So that was great data to have. And then we also added some load cell shifting to improve accuracy and let us see when we're like mis-shifting and actually hitting shifts. So yeah.
All right. So ergonomics and controls, this year we focused heavily on understanding the basics of our design. That was one of the biggest critiques that we got from judges last year, was understanding the basics and building up from that for all of our designs, in particular our braking system. So this year we focused heavily on understanding our temperature and all of those validations for our brake rotors. We made massive redesigns to that. Here's a picture of our brake rotor this year. We also overhauled a lot of the fittings for our brakes. We switched to AM fittings, which allowed us to do in-house manufacturing of our outboard lines. We saw some issues with that temporarily, but we got those fixed and they're working decently now. We also focused heavily on increasing our rigidity of a lot of our designs from our previous years. In particular, our steering system, we increased a lot of the components to be higher quality. It increased weight, but also allows the driver to have better control over the systems. A driver that is able to not have to worry about the controls of the car is able to drive faster. So that was our primary goal with that. Also, it was mentioned along the engine, but we integrated a load cell into the shifting to measure the transmission loading. This allows them to reduce the spark timing so that they can measure the misshifts and then also change it to a closed-loop system. There's a bunch of pictures of stuff. We integrated, we did a lot of FEA on the brake pedals to get a much lighter design. That still needs some work, but we were able to reduce the mass of our pedal box and some other components.
Yeah, so frame and suspension, we are, kind of the thing that everything attaches to and what keeps it on the road. So, yeah, this year we kind of wanted to make sure, again, like some other people have said, we kind of in Design 10 have had, less understanding, especially since a lot of that legacy knowledge kind of got disrupted by COVID a little bit. So this year, we kind of wanted to get a better understanding of our system and also focus on designing based on like data that we get from testing and also be able to add some like testing parameters. Also, 2 years ago, we switched to a carbon fiber monocoque, like Mike was mentioning at the beginning. So half of our frame is carbon fiber instead of all steel. That's kind of been, we've only made 3-4 monocoques now. So we're still kind of in the middle of that learning process. So it's just continuing that process of understanding, what works, what doesn't, how we can improve. And so just keeping to move forward there. But one of the things we're the most proud of that we did this year in the fall semester, we actually took last year's suspension and we chopped up like about in the middle of half of the suspension and we threaded in load cells so that as the car drives and those forces around the tire, they get transmitted through those carbon tubes and each one has like a different load depending on the geometry of it and what you're seeing when you're driving. So in the past years, we've basically just generally scaled some force data that we've gotten, and we didn't have like the utmost confidence in that that's the actual load case that we're seeing. So this year we wanted to make sure that we knew exactly what forces we were seeing and be able to design off of it. So you can see here, it's not specifically that we're threaded in, we drove the car all around and we tested, I think it was 11 or 12 different load cases from like taking the car and picking it up and putting it on our stands and like taking it down or like dragging it around in the halls and loading it into our trailer to everything when we're driving. Basically just trying to completely understand any sort of load case this car would see. We did one test where we had our drivers like spin out and like lock the brakes while they were going in reverse so that like it's like a worst case, emergency situation to see like what forces we see there. And then we were able to optimize what size carbon tubes we have for those load cases. So we were able to, with that in combination with some of the wheel well design that I'll talk about in a second, we were able to drop about 4 pounds from our total suspension system, which is like I think it's like a 13% or so mass reduction. And so yeah, with the wheel well, we made some changes to our simulations, our structural sims to try to both, we realized that there were some constraints that needed to get changed. So we made some improvements there. And also we plugged into more of like a total system deflection sort of like study instead of like looking at each part individually. We decided that we wanted to try to look at like the whole system and its behavior as a whole, because that's what has a bigger effect or a more important effect on how you're handling. In previous years, we just looked at each part and how much it weighs and how stiff it is and set goals individually, but now we're trying to like understand, does this part need to be as stiff as this part? Can they be different? How does that affect handling and making that change? And so, yeah, with that, we were able to drop a bunch of weight out of our uprights and out of our spindles, and it's really exciting. And then finally, our kinematics points for this year, we didn't change a whole lot. We really like, obviously, with third place in autocross, we really like the way the car drives. But we also wanted to be able to test some new parameters. Drivers have complained about steering torque and not having enough of a steering turn radius. So we wanted to tune some parameters for the mechanical trail and pitman arm length. So that we can just add some more parameters to tune and make the car drive as well as we possibly can. All right, so
For the aerodynamics, most of our design this year was improving on the really strong fundamentals we built. So we decided to implement the drag reduction system, which for the first time is operating since 2019 when it was last on the car. See around a 44% reduction in full car drag, about 80 millisecond no load actuation time, probably around 100 milliseconds for as well as that, we need to improve on cooling. With new radiators, we need to fully redesign shrouds. So we have both an inner and outer shrouds to create an airfoil shape on the inlet. And even with these changes, like with the larger radiator shrouds and inhibiting performance, we're still able to increase downforce by 4%, decrease drag by 12%. And we validate all of our designs using SolidWorks flow simulation and ANSYS Fluent, depending on the application. So we have an example of the flow field around the car changing with DRS activating, and you can sort of see how that will reduce drag of the full car.
Yeah, and basically, none of this would be possible without all of our sponsor partnerships. As you can see, we've listed them all here. We've got a bunch. Some contribute monetary values, so basically contribute money. Some contribute in parts, and some contribute in services. So helping us manufacture and build parts. And basically, this team would not exist in this current state without all of these sponsors, every single one of them on this board. And so basically, we'd like to say a huge thank you to every single sponsor that's helped us build this car.
How? I'm just sorry. Why even
Prior process.